Welcome to your new lesson. In this lesson, we'll be interpreting and sketching graphs. Let's take a look at this graph and some questions next to it. This graph represents a scuba diver's dive. Let's answer the question. How many minutes did the dive last? Now let's analyze the graph. We note that the horizontal or independent axis is time, and the vertical axis is the dependent variable, or the depth in the dive of the scuba diver. So we've noticed that the dive occurs for approximately 29 minutes. 29 minutes. Because that's when the diver comes to a depth of 0. At what time did the diver stop her descent? Now descent, that means going down. Going down or going up on a graph does not necessarily mean the same thing. So we have to refer to as the depth. So the diver keeps going down until she reaches the 20-meter mark. That means she's 20 meters below the surface. 20 meters. At what was the greatest depth of diver reached? Oh, pardon me. 20 meters is the greatest depth, while the time for the 20 meters to be reached was somewhere between 8 and 12, which is halfway of 10 minutes. So we have 10 minutes. And what is the greatest depth the diver reached was 20 meters. For how many minutes was the diver at that depth? So we have to look at that she stayed at this depth for this long. From the graph, you could see that it's between 10 and 14 minutes. That's the time. The difference between 14 and 10 is 4. Therefore, she was at that depth for 4 minutes. Let's talk about some properties of graphs. The following graph is a distance-time graph. Why is it called distance-time graph? Because of the labels. And let's explain what occurs at all of these line segments. The first segment, right here, shows an increasing value of distance. The next segment shows a decrease. That means distance is getting smaller. The next shows a constant, non-changing, or no change. The next segment shows a small increase. While the next segment, it shows a small decrease of distance. And the last segment is even a smaller decrease. In this situation, distance over time shows, or it tries to explain, that this is some type of speed. So let's start from the graph. From the left-hand side, we have, maybe this is a car, or this is a person walking. So the person is going at a specific speed. Then the next segment shows that it's decreasing or going backwards. And then there's no change in speed. That means there is no speed at all, for there's no change. So then the person is not moving. Then again moving a little bit faster, and then again going back, and going back again, but just a little bit slower. So last thing, I'm going to label that this is the independent and this is the dependent variable. Let's do an example. Each point on this graph represents a bag of popping corn, or popcorn. Explain the answer to each question below. But before we look at the question, let's take a look at the graph. So the independent variable is the mass, and the dependent variable is the cost. And there are 1, 2, 3, 4, 5 different bags that have a different ratio of cost to mass. Part A asks, which bag is the most expensive? What does it cost? The most expensive bag is the highest point on the graph. It's right here. This bag is C, and it costs, well, let's take a look at the scale. The scale is 1, 2, 3, 4, 5, 6, 7. The scale is 1, but it reaches up to $7. Next question, B. Which bag has the least mass? The least mass will be located to the left-hand side of the graph. And this bag is right here. It is bag B. And its mass is somewhere between 400 and, well, this is 600. It's halfway between 400 and 800. So I imagine it is about 500 grams. Part C. Which bag or which bags have the same mass? And what's the mass? The bags that have the same mass are the ones that are vertically opposite to each other, or in a straight line. These bags are D and E, and the mass they represent is somewhere between halfway between 1,600 grams and 200 grams, which is, 2,000 grams, 1,600 and 2,000 grams, which is 800 grams. So this is D and B. It's at 1,800 grams. Which bag costs the same, and what's its cost? Now we're going to find the horizontal line. In this case, A and B cost the same. A and B cost the same, and their cost is about $4. Part E, which of bags C or D has the better value? So we'll look at C and look at D. Which one has a better value? Well, if we look at D, it has the mass, more mass, therefore it has more popcorn. And also, it's cheaper. It has a mass of 1,800 grams, and it costs about $5.50. So D is cheaper and contains more popcorn. Let's take a look at a different example. In this graph, we have a day trip from Winnipeg to Winkler, Manitoba. It's a distance over time graph. And we need to describe the journey for each segment of the graph. The distance between Winnipeg and Winkler is 130 kilometers. So I took the liberty of labeling the line segment from A to O, A to B, B to C, C to D, and D to E, and explain what is happening here. So for line segments OA, we're traveling at a specific distance, so it's approximately a little bit over 60. So that's about 65 kilometers in 1 hour. So we have some type of speed. From AB, notice there's no distance covered. So we are at a stop. For the line segment BC, we're starting to move again. So we have a speed, or in other words, we have distance covered. For C to D, we're at stop again for some time. And last segment D to E, we go back. We go back. We go back because we notice that distance is decreasing up to the value of, in this case, this reads 0. So we have to be going back. If notice, the distance from Winnipeg to is 130 kilometers, and the graph right here reads approximately 130 kilometers. Let's take a look at the last question. Samuel went on a bicycle ride. He accelerated until he reached a speed of 20 kilometers per hour. Then he cycled for 30 minutes at approximately 20 kilometers per hour. Samuel arrived at the bottom of the hill, and his speed decreased to approximately 5 kilometers for 10 minutes. As he cycled up the hill, he stopped at the top of the hill for 10 minutes. Sketch the graph of speed as a function of time. Label each section of the graph and explain what it represents. Keyword, speed as a function of time, tells you that the y will be in the y-axis of the vertical, and time will be the x-axis as the horizontal. X is the independent variable, and speed is the y, or the dependent variable. I've already took the liberty to do the grid for us, and we'll start. He accelerated until he reached the speed of 20 kilometers. We'll presume that he starts somewhere here. As he somehow accelerated until he reached 20. We don't know for how long he accelerated for, so we're going to make it very small. Then he cycled for 30 minutes at approximately 20 kilometers. So approximately 30, so a little bit past 30 because he accelerated for that short time, he will be at a constant velocity at 20 kilometers per hour. The next part, Samuel arrived at the bottom of the hill, and his speed decreased to approximately 5 kilometers per hour for 10 minutes. I'm going to go back to approximately, where's 5 kilometers? Somewhere right here. And he traveled that distance, so that speed for 10 minutes. So approximately here. So this span is 10 minutes at a constant velocity. Then the next part, it says, as he cycled up the hill, he stopped for 10 minutes. So he had to slow down. And now velocity is at 0 right there. And that has to happen for about 10 minutes. It's approximately here. So now let's explain what each segment represents. The first segment shows acceleration. Samuel, or Sam, accelerated his bike. Then the top part, it's constant velocity, so velocity doesn't change, or speed doesn't change. Constant speed. Then as he goes, then he decreased his speed or decelerates. The flat one is that he's again at constant speed. He again decelerates. And then the last part, he has stopped.